So thanks very much for the introduction. There's a lot of stuff that I think we'll also mention in our talk as well. I also wanted to very quickly mention that with me, I also have Bastian Echtelholter, who is our architect and help us, show us a little bit of a demo on how we want to sort of show a little bit of a vision of the platform mesh to help you understand, because we've had a lot of questions about how does the platform mesh work, what are some of the use cases can be for, and we understand that, it's a little bit of an abstract topic. So we'll try to give you as people as much content and possibilities and also the chance to ask questions as well at the end then. With that said, just like Christian was saying, there are a lot of projects under NeoNephos. What I also want to highlight is, of course, we'll be talking about the platform mesh per se. But the one key point I wanted to say, though, is that we do also use other projects. So we do eat our own dog food. We also use OpenMFP for the UIs, for be able then to have, you have a Kubernetes API that you then want to represent a better user experience. So we use OpenMFP for that. We also use the OCM for packaging specific components that can then be also installed. So later on we talked about managed service providers, how they can also install some of those dependencies. OCM is one way to do that. But of course, there are other projects in there that you might also be interested in to look into it as well. Now, coming now to the actual key points here in terms of the platform mesh. The platform mesh itself is trying to look at what we sort of refer to as the multi-provider cloud edge continuum. Okay, so in this continuum, there are different providers of services that are then available. You might have your infrastructure providers, you will also have your software providers. So you think about the cloud edge continuum as this overall computing architecture where you have compute on cloud and compute on the edge, and they serve different purposes. But they all offer different types of services that we then want them to consume and have them available. At the very coarse level, and we look at it, we see that there's two ways to segregate this. You have then the software providers on one side, who always want them to be flexible and mobile for your needs as an application user or application developer who depends on these services. But you also then at one side, you also have the infrastructure providers, and these infrastructure providers by design aim, for a lock-in and control. Now that's a bit of a challenge though, because the two needs to play together, but they have different commercial objectives, and this ultimately leads to the lock-in problem, the vendor lock-in problem. You have these proprietary APIs where each provider speaks their own language. There's no standardization per se. Each vendor has also its own dependencies, which means that switching providers means rewriting integrations. You have this skill fragmentation where teams then need specialists for each provider ecosystem that they want to implement. And you also have this innovation barrier. So when you think about a small European providers that can't compete with the established ecosystems, but just to step back a little bit and says like, well, is this really a technology problem? When you think about it, it's mostly about standardization. So the infrastructure exists, but there is no common way to use it effectively. I will go a little bit into that. And even when you look at inside one of those providers, we see a very similar behavior.
Mirza? Okay,
yes.
now the slides changed for me, but we saw the same slide until now.
Okay, sorry. And yeah, so when you now look inside one of those specific providers, if you look at the classical definition of a stack, you'll have these artificial barriers. You'll have your infrastructure service, you have your platform as a service, you'll have your software as a services, and then you have these tight dependencies between each of those artificial layers that require to have this between each other. Of course, these artificial boundaries, they are there, but they are controlled then by the provider, But then the provider itself says that, well, if you wanted to use some of those, and if you want to build some business value with these, I'm going to provide an opinionated administrative management API. You can pick and choose your words from there, but the key point is that there's an administrative domain for this vertical stack, and you need to have some way then to manage that. And of course, they're going to give them their own flavor of what they think should be. And in the background, they're patching, they're gluing things together, they're building bridges between some of those silos, between also some of those barriers that are there between, infrastructure and platform as a service, wherever it might be. But the problem is that, they try to offer their management interface for these diverse components into a cohesive platform. And this is where the APIs are meant to create the vertical integration from the business logic to the infrastructure itself. Okay. So then we come back to the challenge now with that in mind, and we says that, well, looking at the cloud edge continuum, we have these incompatible APIs across those providers. We have this increased exponential complexity when adding new providers. If you're a consumer of those providers, for every new provider that you add, you have to speak a specific domain. You need to have that opinionated management API that you need to understand. You have these proprietary interfaces that you also need to understand that as well. And then again, there is this no consistent way to consume those services across that continuum. And when you then look at it, you put yourself in that situation and says that, well, I am an application team. I'm a consumer of those services that wants to build an application, as an example, and say, I have a service from provider A, and I have a service from provider B. Now I rely on both of those, but the heavy work, the burden lies with me to do that integration. So you have this fragmentation. That means that, I'm the one who has to do all of these integrations. And in the end, it comes down to you to do all of this work, whatever tools you might be using. But your problem is that you have to deal with those opinionated APIs in your own way. And then you, of course, might be wondering is that, well, what if there was a way to make all of these providers speak the same language? And looking back at that stack, well, actually, we're not that far off from that question, because if you look more closely in this vertical stack, you will see that cloud native has already changed that landscape. And there are open source foundations that are driving that change. There are these paradigm shifts that are happening. And they are driven by these open source platforms. That's by open source in today's platforms today. So therefore, these managed service providers, as well as consumers, are already using Kubernetes. So there is no need to invent something completely new. There's no point in to bring you another thing that you have to do. You are already using it in your stack. And if you're an MSP, you're probably already using Kubernetes as is. And the key point here is that we're not talking about Kubernetes as an orchestration engine. We're talking about exposing the kube API as a control plane to be able then to use Kubernetes resource model to manage specific the concept of digital twins for services and resources that can be part of a mesh. Okay? And we do this, we're looking at providing then this harmonized way to combine it into one way to speak across all of those services, and that is using the Kubernetes resource model. So why in the Kubernetes resource model, then you will then have your KRM as your Franco-lingua, where you then have every service capability that becomes then a digital twin, where you then define a live declarative contract between what you want and what you get, thereby bridging the gap between these different cloud providers. And of course, then, where would this happen? Well, you wouldn't have this concept of control planes. So in Kubernetes, there are these control planes as well. We are here using a project called KCP. You can check it out. It's KCP.io that offers these user-facing control planes for us. Now, when you think about that, well, what's really the motivation for the platform mesh then? It's based on sort of the same principles like Kubernetes. It's supposed to be API-centric, not API-driven architecture. It's designed to be where API server manages the state, but the business logic runs outside the API server with loosely coupled controllers. You have this concept of declarative management and digital twins. Platform mesh heavily relies on a declarative approach using the Kubernetes resource model to define the desired state of those resources. So make those controllers work for you. You also then think about choreography. The design is based on concepts of choreography. It's multiple separate resource abstractions and controllers collaborate to achieve a desired emergent behavior without necessarily a central orchestrator in the middle. And of course, you have KRM as your lingua franca. KRM serves as the common language for all declarative service management, simplifying the interactions and then enabling this cross-provider service compositions. And of course, the platform mesh recommends Opera-based installations, to update these procedures, to shift the responsibility of the lifecycle management to product-specific operators. So this also allows for automated adjustments to bring the target environment into the desired state. And the aim of this is that we're trying to foster European digital sovereignty with this. We are being funded by public money from the EU, and we're also then trying to build a framework that can be used within EU for these types of problems that exist with the Cloud Edge Continuum. Now, coming back again to the business experience, there is still this concept of fragmentations and these lock-ins. The teams must master these multiple opinionated platform APIs, where each integration becomes a custom Snowflake solution. So you keep that in mind as you look at the continuum, and says you look into specific vendor systems. So what needs to happen? Well, this needs to be disrupted. And the way to do this is to provide then a practical standardization approach. You can then order through a common interface, that is Kubernetes resource model, the first step towards a vendor agnostic standards. No need for a standardization body involvement per se, because you already have this. Okay. So we'll quickly show a demo coming up shortly, but I wanted to do about it is that show you a bit of a diagram to help understand the demo a little bit better. In the concept of talking about orders and fulfillments and the representations of digital twins, if there is an order that comes in from the platform mesh, it would then be represented on the actual managed service provider that takes that order, creates the fulfillment on their side, and then is able then to have that workflows that is then can be used and interacted with many different ways. Such an example of the HB bin, we use that in our examples. It's a very simple example that developers generally understand, and they use it for a lot of the APIs testing and the UIs as well. And the idea is that as soon as this order is fulfilled, it's available on the managed service provider, the status then is synced back to the platform mesh, where you then the digital twins represent that representation of this exact order that you've then had. Your desired state then is then also represented in the mesh as well. Okay, well, with that said, I will then hand over to Bastian, and we can get the demo started shortly.
Sounds good. Yeah, maybe this is another slide that will outline a little bit on what you're going to see in the demo. So as Mirza said, we're going to use this example of ours that we call HDD bin as a service provider. So imagine that this is representative of a managed service that you could order, and basically what will happen is that we will make this HDD bin API available in a user account or user workspace, and this is sort of what this first level here indicates. And so we can create a resource of HDD bin in that workspace. If you click one more time, then there's a representation or a linking of that into the provider workspace. And then basically it gets transferred to the provider side. And we will mimic this, showing like it would be an edge sort of provider by running this on my local system. And there's a KCP component called sync agent. And this component basically transfers the order from the platform mesh installation to the operator installation and fulfills the order. And then as a result, we will be able to see the result. This will probably be the end goal. So basically to show you how to register a new provider into platform mesh, and what this will mean for you, and to show you some more details on how this would feel. But for that, let me start sharing my screen.
I'll stop sharing light. You can go ahead.
Okay, I hope you can see it.
We can see your screen.
Do you see the
Yes.
showroom?
Yes, we do.
So yeah, I'm going to demo this from a showroom. This is a remotely deployed platform mesh installation that we have here at SAP to showcase some of the features. It's in our dev environment, so you see some development related assets here. But yeah, so the first thing I'm going to do is to create an account. An account is similar to what you probably know from hyperscaler or so, basically an entity that allows you to group your work. So we'll go ahead and do that. Call it demo. And create this account. Now, for each account in the platform mesh, you will get what we call a workspace in KCP. So it's already indicated here via this path. And I will always go back and forth between sort of the UI that basically shows what we have in platform mesh and also this very same thing that you can see via kubectl to always reiterate the fact that basically this is just a UI to show you what's in the community space or KRM-based control plane. So I will switch to that real quick. So in KCP, you can sort of switch between workspaces, and this is what this WSUse command does. So I'm switching now to this new workspace that I have just created. So a new workspace in KCP comes in with very minimal API resources. So it's the bare minimum that you get. So you have some things you may recognize from Kubernetes. So things like namespaces and config maps. It also brings some pure RBAC things like cluster roles and so on, and a few APIs we introduced from platform mesh. But there's not much more. So you will not see any workload related types, for example. So no deployments, no pods, and so on, because this is purely about the API exposure, not about any runtime aspects. Now, when I look in this newly created account, there's already an example provider. We have pre-registered some infrastructure provider, and I can go here and install it. And what means installing it basically means I want to use this provider and I want to enable the APIs for me. So if I go back to KCP now and run the same API resources command, there are a bunch of infrastructure related APIs now showing up that did not show up earlier, right? So now I see clusters and load balancers. And the very same thing is also happening on the UI level. So I can, in this case, the infrastructure provider resources are namespace. So these Kubernetes entities for namespacing. So again, a mechanism for grouping resources. So it does also apply here. So can create a default namespace. And if I go into the default namespace now, I see a bunch of infrastructure related resource to show, as an example here. So for example, I can create a cluster with something. And I can do the very same thing also on kubectl. So if I then say get clusters, I see the dev cluster I just created, with the input I had in the UI, right? So there's always the UI will show a representation of what you also see in the KCP-based control plane. Okay, so this shows a little bit on how you could leverage an already existing provider that is activated in your platform mesh installation. So now the next goal would be, how would I bring a new provider into this? And here we want to introduce this HEBin provider that we mentioned at the beginning. Now, there are a few things that a provider currently has to bring. And one thing is what is called an API export. And that is basically sort of a reference point that we would use when you install an API and you basically say, I want to bind to this API export. As you can see, there's not much in there. And we will enrich this with a link to the API definitions later on the demo. There's also a UI configuration. So in this case, we're going to introduce a micro front end for this HEBin that runs somewhere. And thirdly, there's some metadata around the provider. This is basically what you can see, in this catalog view, that we have some contact person, some descriptions around the service. Now let me prepare this. So I have a little script that loads the files. So I don't have to do this in the live demo. But basically what happens is we create a provider workspace where those resources would be, and then I just loaded the YAML files that that I showed you. So I can switch to that as well. And here you can see now, for example, the API export that I have just loaded. Now, what you will not see is another resource that's called API resource schema. Because that one is going to be filled when I start the actual provider. So basically, this is part of the provider implementation that the provider can tell the platform mesh, how do my APIs look like? So for that, I'm now switching basically over to the provider now. I'm basically installing the provider on my local system. So to do that, I have a little kind setup that I'm going to start. And while this is coming up, I can also explain some of the tools that we use to run this provider now locally. This won't take too much time, I hope. So let me switch. Yeah, so the first thing that's going to come up is primarily also Flux. So we use Flux for sort of GitOps-like mechanics and Helm releases within this kind cluster. You also see Nginx, because this is an application that is exposed. We use an Nginx controller here to expose the app. We also use Crow. So Crow is a technology that you can use to sort of pipeline a set of resources in form of a graph. We use this to deploy or orchestrate the deployment, if you will so. And we also use OCM, so the Open Component Model. And the Open Component Model is a spec basically that allows you to describe your applications in a tree of components. So in OCM, you can specify, this is my Helm chart, this is my image and what version. And this will help you to structure your deployments, but also to, for example, lifecycle applications into, for example, locked environments. Now I have installed the preconditions. Now I'm basically deploying the operator. So what this does is it will create the necessary OCM resources. So we should see, for example, a repository. It's a link to the OCI repository. There's a component resource that says I want to deploy version 0.57 of this operator now. There's also a resource, and here you basically link to, okay, I want to use the Helm chart of that operator in this case. And this leads then to original Flux resources like the OCI repository. And when that is there, a Helm release is triggered. And with that Helm release, you then get your operator deployment, which is now here and should be running now. So with the running provider on my local client, we should now see, I didn't mention the API sync agent. So this is the sync agent you saw on the diagram earlier, which is in charge of synchronizing the resources from Platform Mesh to this local client environment. So we should see now already the update of my provider installation. So if I look at the API resource schemas now I see one. And this API resource schema is basically what you may know from custom resource definition. So it basically contains the Open API specification of the API of that provider. And now this is known to KCP, and I can then use it in Platform Mesh. Okay, so going back to my browser, now I see the second provider that is registered now, and I can use it. So installing this as well. So going back to my namespace, next to the infrastructure UIs, I now see the HG bin UIs. So I can create a new bin, it's called dev. And as before, if I switch now back to the user workspace, I will see the HG bin resource, HG bin, so the one I just created. And it are, you see, for example, the enable HGS that I provided, but you can already see a status update. So this was nothing that I provided. This is already feedback from the provider. The very same thing you will see here on my local client now. So also this client has the very same resource. So I can look at HG bins. And this is the bin that was just synchronized, from the remote platform mesh to my provider. And the provider acts now on this order and creates, for example, a deployment. So there's now a very new deployment that actually deploys this service that was ordered. The provider now will at some point then update this resource to indicate, okay, this is ready, this can be used. So yeah, now it happened. So basically now my bin is ready. The very same thing, of course, will be updated also here. So you see the ready is here as well. And this also means on the UI level, the progressing button is gone. And now I can open the application, which is also running locally. And this sort of shows the end-to-end sort of fulfillment of a resource that was requested via the platform mesh. Yeah, maybe to reiterate a little bit on what we've shown. So basically, we introduced the concept of accounts and how you would enable a certain provider, how these provider APIs are visible in the respective community space control plane, and then how the fulfillment process would look like towards a provider. Yeah, I think this is all that I had to show for the demo for today. Maybe one thing to maybe reiterate or state is, as we build fully on the Kubernetes resource model, of course, the whole CNCF ecosystem of tools is at your hands, right? So we're fully compatible with Kubernetes in that regard. So you can use, tools you may already be using to also orchestrate resources within Platform Mesh naturally. Okay. Then I think back to you, Christian.
Yeah, thank you very much for the presentation. And I also want to say we don't want to reinvent the wheel and create these components over and over again. So we are not in a competition with the CNCF, but we want to focus with the NeoNephos Foundation on our area and to reuse as much as possible.